Close your eyes for a moment. Picture the last sunset you watched. Maybe it was golden. Perhaps it painted the clouds in soft pink and orange. The light felt warm on your face. Familiar. Comforting. Now imagine that same feeling. But the sun hanging in your sky glows deep red like a ruby. Or brilliant blue-white like a diamond. Or perhaps two suns dance together. One orange. One silver. Casting double shadows at your feet. This is not fantasy. This is the universe we live in. Your sun. Our sun. The star that has warmed Earth for billions of years. It burns at about 10,000 degrees. That temperature creates the golden light you know so well. The light that makes leaves green. The light that turns evening clouds into watercolor paintings. But your sun is just one star among hundreds of billions. Each star burns differently. Each star creates its own unique color of light. And each star, if it has planets, paints those worlds in colors you have never seen. Think of a campfire. When the flames are small and gentle, they glow orange and red. As you add more wood, the fire grows hotter. The flames turn yellow, then white, then blue-white at the very center. Stars work the same way. The coolest stars burn red like dying embers. They are called red dwarfs. Imagine standing on a planet orbiting such a star. Your entire world would be bathed in crimson light. The grass, if grass could grow there, would appear deep burgundy. The sky would glow like wine. Hotter stars burn yellow, like your sun. Even hotter stars blaze white. The hottest stars of all burn brilliant blue. Picture yourself on a world circling a blue giant star. Everything would shimmer with cold, electric light. The shadows would be sharp and silver. The horizon would gleam like polished metal. But here is something wonderful. Your eyes. The eyes you were born with. They evolved under your sun's golden light. They learn to see the world in the colors your star provides. Green plants. Blue skies. Red roses. If you were born on a world with a red star, your eyes would see differently. What looks red to you now might appear bright and colorful to someone who grew up in crimson light. Their world would be full of beauty. Just different beauty. Scientists have found thousands of planets beyond our solar system. We call them exoplanets. Worlds orbiting distant stars. Each one receives light from its own sun. Each one experiences its own kind of sunset. Some of these worlds orbit very close to their stars. So close that one side always faces the sun. Like how the moon always shows Earth the same face. On these planets, one half bakes in eternal daylight. The other half freezes in endless night. But right at the border, in the twilight zone between day and night, the sun hangs forever at the horizon. A permanent sunset that never ends. Other worlds swing around two stars at once. Binary systems, where stars dance together like cosmic partners. Imagine watching the sun set on such a world. One star drops toward the horizon, painting half the sky orange. Then the second star follows, adding layers of blue or red or silver. The colors would blend and shift, creating sunsets that last for hours. The air on these distant worlds, the atmosphere, also changes how sunsets look. Your Earth's air is mostly nitrogen and oxygen. Clear gases that let golden sunlight pass through easily. But other worlds have different air. Some planets have thick atmospheres full of methane. The same gas that makes blue flames on your stove. On these worlds, sunlight would filter through methane, turning everything pale blue. The sunset would glow electric blue, like looking up from the bottom of a swimming pool. Other worlds have no air at all. just like your moon. On these planets, the sun would appear as a brilliant point of light against a black sky. Even during the day, the sunset would be sudden, sharp. The sun would simply disappear behind mountains or horizons. No gentle fading. No soft colors spreading across clouds. Just light. Then darkness. Water in the air creates some of the most beautiful sunsets. The tiny droplets scatter light, breaking white sunlight into rainbows. Your Earth sunsets glow red and orange because blue light scatters away during the day. Only the warm colors reach your eyes at sunset. But imagine a world where the air holds different kinds of tiny particles. Dust made of iron. Or crystals of salt. Or droplets of liquid methane. Each type of particle would scatter light differently, creating sunsets in colors that have no names. As you drift toward sleep tonight, let your mind wander to these distant worlds. Picture yourself standing on solid ground, looking up at an alien sky, watching as an unfamiliar sun begins to set. The light feels different on your skin. The shadows fall at strange angles. The colors in the sky shift and dance in ways that seem impossible. Yet somewhere, right now, these sunsets are really happening. On worlds so far away that their light takes years to reach us. Your journey to these distant sunsets is just beginning. Tomorrow night, we will visit a world where the sun glows red like an ember, where twilight lasts forever. Let your mind drift to a world bathed in endless twilight. Here, the sun never blazes bright yellow like yours. Instead, it glows soft red, like coals in a fireplace that have burned low but never go out. This is a red dwarf star, the most common type of star in the universe. These gentle giants burn cooler than your sun. Much cooler. Where your sun reaches 10,000 degrees, a red dwarf stays around 6,000. That difference changes everything. Picture yourself standing on solid ground beneath such a star. The light touching your face feels warm but gentle. Never harsh. Never blinding. The sun hangs in your sky like a large red marble. Beautiful and calm. Everything around you glows in shades of crimson and burgundy. The rocks at your feet appear deep red-brown. Any water would catch the red light and shimmer like liquid garnets. The sky itself would glow soft pink, fading to deeper red near the horizon. Your shadow on this world would be sharp and dark. Red light creates clear shadows because it travels in straight lines, unlike the scattered yellow light of your home sun. Here, you could read by starlight. The gentle red glow would be steady and reliable. Red dwarf stars live much longer than stars like your sun. Much, much longer. Your sun will burn bright for about 10 billion years total. It has already lived for 5 billion years. So it is middle-aged. Like a person in their 40s. But red dwarfs burn slowly. Carefully. They sip their fuel instead of gulping it down. A red dwarf can shine for hundreds of billions of years. Some will outlive your sun by more than 50 times. They are the tortoises of the star world. Slow and steady and almost eternal. This long life creates something wonderful. Stability. On a world orbiting a red dwarf, the seasons would stretch across centuries. The weather patterns would be slow and predictable. Life would have billions upon billions of years to grow and change and adapt. Imagine generations of creatures evolving under that gentle red light. Their eyes would develop differently than yours. Where you see 3 main colors, red, green, and blue, they might see dozens of shades of red. What looks like one color to you would be a rainbow to them. Plants on such a world would be different too. Your Earth's plants are green because they reflect green light and absorb red light for energy. But on a red dwarf world, plants might be black or dark purple, absorbing every bit of that precious red light, using it all to grow and thrive. The air on these worlds would feel familiar yet strange. If the planet has an atmosphere like Earth's, you could breathe easily. But the light filtering through that air would create colors you have never seen. Sunrises and sunsets would last for hours. The sun would take its time climbing up the sky and sliding back down. Many red dwarf planets orbit very close to their stars. So close that they become tidally locked. This means one side of the planet always faces the sun. Like how one side of the moon always faces Earth. The day side stays warm. The night side stays cold. But along the border, in the twilight zone, the temperature stays just right. Picture walking through this twilight zone. The red sun hangs motionless at the horizon. Never rising. Never setting. Just glowing there like an eternal sunset. The temperature around you feels comfortable. Not too hot. Not too cold. Perfect for life. In this twilight band, gentle winds would blow constantly. Warm air from the day side meets cool air from the night side, creating breezes that flow around the planet like invisible rivers. These winds would carry water vapor, seeds, the building blocks of life from one side of the world to the other. Scientists have found many planets orbiting red dwarf stars. Some are close to Earth's size. Others are larger. A few might even have oceans. Imagine vast red seas under crimson skies. Waves that glow like liquid rubies as they catch the starlight. The water cycle on these worlds would be slow and steady. Like everything else under a red dwarf's glow. Oceans would evaporate gently. Clouds would form gradually. Rain would fall softly. Everything moves at the pace of deep time. Patient and unhurried. If you lived on such a world, your sense of time would change. Days and nights that last for months would feel natural. The slow dance of seasons across decades would seem normal. You would learn to think in longer rhythms. To plan not just for tomorrow, but for centuries ahead. The night sky on a red dwarf world would be spectacular. Without the bright yellow glare of a sun like yours, the stars would shine more clearly. Other red dwarfs would dot the darkness like distant campfires. The galaxy would spread across the sky like spilled glitter. During the rare times when the red sun dims behind clouds, the world would not plunge into darkness. Instead, it would glow with a soft, wine-colored twilight. Even the dimmed light would be enough to see by. Enough to feel warm and safe. This is the universe's most patient light. Red dwarfs will keep shining long after hotter stars have burned out and died. They will provide warmth and energy for life forms we cannot yet imagine. On worlds that spin slowly through time like gentle dancers. As you settle deeper into sleep, let yourself imagine the peace of such a world. Where time moves slowly. Where the light is always gentle. Where you could spend lifetimes watching the subtle changes in a crimson sky. But not all alien worlds move with such patience. Some dance with two stars at once, creating sunsets that paint the sky in layers of impossible color. Imagine looking up at your sky and seeing two suns hanging there like celestial siblings. One glows warm orange. The other shines cool blue-white. They move across your heavens together. Sometimes close. Sometimes far apart. Always dancing. This is not imagination. This is reality on worlds that orbit binary stars. Two stars that circle each other in an endless cosmic waltz. Nearly half of all stars in the universe have stellar companions. Your single sun is actually unusual. Most stars prefer company. Picture yourself standing on solid ground beneath these twin lights. The warmth on your face comes from two sources. The orange star feels familiar. Like your home sun on a gentle autumn day. The blue-white star adds a cooler touch. Like moonlight mixed with sunshine. Look down at your feet. You cast two shadows. One shadow falls toward the orange star. Another reaches toward the blue star. As the stars move across your sky, your shadows dance around you. Sometimes they stretch in opposite directions. Sometimes they overlap into one dark shape. Sometimes they disappear completely when both stars shine directly overhead. The ground beneath you glows with mixed light. Orange and blue blend in ways that create new colors. Where the warm light meets the cool light, everything shimmers with gentle purple. The rocks around you appear painted with invisible brushes, constantly changing as the twin stars move. Binary star systems come in many types. Some stars orbit very close together, so close they almost touch. These stars dance quickly, spinning around each other in hours or days. Other binary pairs stay far apart, taking hundreds of years to complete one slow orbit. The stars in your imagined sky might be similar in size. Twin orange giants that cast equal light. Or they could be mismatched partners. A large bright star paired with a small dim companion. Each combination creates different lighting, different shadows, different sunsets. When sunset begins on your binary world, magic happens. The first star starts to sink toward the horizon. Let us say it is the orange one. The sky on that side of your world begins to glow with familiar warm colors. Soft yellows fade to deep reds, just like sunsets on Earth. But then something wonderful occurs. The second star, the blue-white one, still shines high above you. Its light mixes with the orange sunset, creating colors that have no names. The western sky might glow purple and gold. The eastern sky stays bright silver blue. As you watch, your shadows continue their dance. The orange star casts a long shadow behind you. The blue star creates a shorter shadow to your side. The two shadows move like partners in a slow ballet, reaching toward each other, pulling apart. Never quite the same from moment to moment. The orange star disappears behind distant hills. For a few minutes, you live in a blue-white world. Everything around you takes on a cold, pure light, like standing inside a diamond. Your single shadow grows sharp and clear beneath the remaining star. Hours later, the blue-white star begins its own descent. Now the sky transforms again. Blue-white light filters through the atmosphere differently than orange light. It creates sunsets of pale silver and soft violet, colors that seem to glow from within. If both stars set at the same time, the spectacle becomes breathtaking. Orange light streams from one horizon. Blue-white light pours from another. The entire sky becomes a canvas of blended color. Purple and gold and silver and rose, all shifting and flowing like aurora painted across the heavens. The weather on binary worlds would be complex and beautiful. Two stars mean two sources of heat. The temperature changes as the stars move closer together or farther apart. Winds blow in patterns that spiral and curve, following the mixed heating from twin suns. Seasons on your binary world would be unlike anything on Earth. Instead of simple summer and winter, you might experience 4 or 6 different seasons. Times when both stars shine directly overhead. Periods when they hang on opposite sides of the sky. Months when one star hides behind the other, creating a cosmic eclipse. During these eclipses, day would gradually turn to night as one star slides behind its partner. The temperature would drop. Animals would pause in confusion. Plants would fold their leaves. Then, as the hidden star emerges, light would flood back across your world like a gentle dawn. The night sky on a binary world would be extraordinary. When both stars finally set, the darkness would be profound. Your eyes, adapted to twin starlight, would see the distant universe with stunning clarity. Other binary systems would twinkle like paired jewels. The galaxy would spread overhead like spilled stardust. Some binary worlds experience double dawns. First one star rises, painting the eastern sky with its unique color. Then the second star follows, adding its light to the mix. Morning becomes a gradual symphony of increasing brightness, each star contributing its voice to the growing day. The plants on such worlds would be master chemists. They would need to capture energy from 2 different types of light. Orange light and blue-white light carry different amounts of energy. Plants would evolve complex systems to use both. Their leaves might change color throughout the day. Green in orange light. Purple in blue light. Rainbow-colored when both stars shine together. Water on binary worlds would sparkle with double reflections. Lakes and rivers would catch the light of both stars, creating patterns that shift and flow like liquid prisms. Rain would fall through mixed starlight, each drop becoming a tiny lens that splits the twin light into miniature rainbows. As you drift deeper into your cosmic journey tonight, let your mind rest on this image. Two suns moving slowly across an alien sky. Your shadow dancing at your feet. The air around you glowing with impossible colors. This is the universe showing off. Taking something as simple as a sunset and turning it into performance art. Two stars. One sky. Infinite beauty. But even this spectacle would seem ordinary compared to worlds where the very air glows blue, where familiar chemistry creates alien wonders beyond imagination. Take a deep breath and imagine air that glows blue around you. Not the pale blue of Earth's sky, but deep electric blue. Like looking up from the bottom of a clear swimming pool. This is the methane sky of distant worlds. Methane is a simple molecule. For hydrogen atoms wrapped around one carbon atom. On Earth, you know it as natural gas. The blue flame on your stove. The gas that bubbles up from swamps. But on cold worlds far from their stars, methane becomes something magical. Picture yourself standing on Titan, Saturn's largest moon. The air here is thick with nitrogen, just like Earth's atmosphere. But instead of water vapor, the air holds clouds of methane. Invisible methane gas floats all around you. And when sunlight passes through this methane-rich air, something beautiful happens. Methane scatters blue light more than any other color. The same way Earth's atmosphere scatters blue light to create your familiar blue sky. But methane does this much more strongly. The result is a sky so deeply blue it seems to glow from within. The sun in this methane world appears dimmed and distant. It might be Saturn's pale yellow disk, seen through layers of blue haze. Or it could be an alien star, filtered through an atmosphere unlike anything on Earth. Either way, the sunlight that reaches you has been transformed. Softened. Made ethereal. Look around at this alien landscape. The ground beneath your feet might be made of water ice, hard as rock in the freezing cold. Hills and valleys stretch toward the horizon. But everything appears tinted blue by the methane air. Even your own hands would look blue in this light. The weather on methane worlds follows patterns that seem familiar yet strange. Clouds form and drift across the blue sky. But these are not water clouds. They are made of methane droplets. Tiny spheres of liquid methane that catch and scatter the filtered sunlight. When these methane clouds gather and darken, rain begins to fall. But this is not water rain. Drops of liquid methane patter down from the blue sky. They pool in rivers and lakes of liquid methane. These alien storms move slowly across the landscape, bringing methane rain to methane seas. The sound of this alien rain would be different from Earth rain. Methane is less dense than water. The drops would be larger but lighter. They would fall more slowly, creating a gentle pattering sound, like soft drumbeats on a distant stage. As sunset approaches on your methane world, the blue sky begins to change. The sun, already dimmed by methane haze, starts to sink toward the horizon. But instead of the warm oranges and reds of Earth sunsets, something cooler happens. The blue light deepens. Layers of methane haze create bands of different blue shades. Deep sapphire near the sun. Pale azure higher in the sky. Steel blue along the horizon. The entire world seems to be lit from within by blue fire. Methane haze does something else beautiful. It creates layers in the atmosphere. Different altitudes hold different amounts of methane. As sunlight passes through these layers, it bends and shifts, creating optical effects that make the sun appear to dance. The setting sun might seem to stretch into an oval, or split into multiple images, or shimmer like a mirage. These are the same effects that create mirages in Earth's deserts. But here, in the methane sky, they happen constantly. The air itself becomes a lens that bends and plays with light. Temperature plays a crucial role in methane worlds. Methane only stays liquid in a narrow range of cold temperatures. Too warm, and it becomes gas. Too cold, and it freezes solid. The worlds where methane rain falls are perfectly balanced. Cold enough to keep methane liquid. Warm enough to keep it flowing. This creates seasons unlike anything on Earth. As the world moves closer to or farther from its sun, the methane cycle changes. In warmer seasons, more methane evaporates from the lakes and seas. The blue haze becomes thicker. The sky grows deeper and more intense. In colder seasons, methane condenses out of the air. The blue haze clears slightly. You might see farther across the landscape. The sun appears brighter through the thinner atmosphere. But the overall color remains that haunting, beautiful blue. Scientists have found evidence of methane in the atmospheres of many worlds. Some are moons like Titan. Others are planets orbiting distant stars. Each one creates its own version of the blue methane sky. Some deeper. Some paler. All breathtakingly alien. The chemistry of methane worlds extends beyond just the atmosphere. Methane dissolves other organic molecules. The lakes and seas on these worlds might contain complex chemistry. Simple molecules combining into more complex ones. The building blocks of life forming in seas of liquid methane. Imagine dipping your hand into a methane lake. The liquid would feel thin and light. Like touching liquid natural gas. It would be clear as water but completely alien. Molecules that could never exist in Earth's warm oceans floating freely in the cold methane. As night falls on your methane world, the blue glow fades gradually. But it never completely disappears. Even in darkness, traces of scattered light create a faint blue luminescence in the air. Like being inside a giant blue lamp that has been dimmed but not turned off. The stars above shine through layers of methane haze. Their light, too, becomes tinted blue. Constellations that would appear white or yellow from Earth glow with soft blue light. The entire universe seems painted in shades of azure and sapphire. As you settle into the peaceful blue twilight of this alien world, your mind begins to wander toward other mysteries. Not all worlds dance around their stars in familiar patterns. Some hang motionless, creating realms of eternal twilight more strange and beautiful than any methane sky. Imagine a world where time has stopped. Not really stopped, but slowed to match the rhythm of the planet's orbit. Here, one side of the world always faces the sun. The other side always faces the cold darkness of space. And between them lies a band of eternal twilight. This is what scientists call a tidally locked world. The same gravitational forces that keep Earth's moon showing us only one face have locked this planet to its star. It spins exactly once for every orbit it makes. Day and night become places instead of times. Picture yourself standing in the middle of this twilight zone. The sun hangs motionless at the horizon. Never rising. Never setting. Just glowing there like a permanent sunset that stretches across centuries. The light on your face feels warm but not harsh. Gentle but constant. Look toward the day side of your world. In that direction, everything glows with brilliant light. The ground shimmers with heat. Rocks might glow red hot. Any water would boil away into steam. The air itself would be too hot to touch. It is a realm of perpetual noon where nothing can survive the constant burning. Turn around and gaze toward the night side. There, eternal darkness reigns. The cold is so complete that the air itself might freeze solid. Any oceans would be locked in ice miles thick. It is a frozen wasteland where the only light comes from distant stars. Beautiful but deadly in its perfection. But here, in your twilight zone, the temperature stays just right. Not too hot. Not too cold. The sun provides exactly enough warmth to keep water liquid. To keep the air breathable. To make life possible in this narrow band around the world. The sky above you displays colors that never change yet never stay the same. The sun sits at the horizon in eternal sunset position. Around it, the sky glows with deep oranges and soft reds. These colors fade gradually to purple, then deep blue, then black as you look toward the night side. But the atmosphere is always moving. Winds blow constantly from the hot day side toward the cold night side. These winds carry clouds and moisture. The colors in your twilight sky shift and flow like a slow river of light. Always sunset colors. Always beautiful. Always changing. Weather in the twilight zone follows patterns unlike anywhere else. Hot air rises from the day side and flows high overhead toward the night side. Cold air from the night side slides along the ground back toward the day side. This creates constant circulation. A planetary scale engine that never stops. Clouds form where the hot and cold air masses meet. These clouds follow the boundary between day and night. They create a ring of weather around the entire planet. Sometimes the clouds thicken and bring gentle rain to your twilight realm. Sometimes they clear and let the eternal sunset shine through. The landscape around you would be shaped by these constant winds. Sand dunes would all point in the same direction. Rivers would flow in predictable patterns. Plants, if they could grow here, would lean toward the day side like flowers following the sun. Water plays a special role in tidally locked worlds. On the day side, it boils away. On the night side, it freezes solid. But in your twilight zone, water can exist in all three forms. Liquid rivers and lakes. Water vapor in the air. Ice where the shadows fall deepest. This creates a water cycle unlike Earth's. Water evaporates on the day side and gets carried by winds into the twilight zone. Here it condenses into clouds and falls as rain. The rain flows in rivers toward both the day and night sides. Some water returns to the hot side to evaporate again. Some flows to the cold side and freezes. Imagine standing beside a river in this twilight realm. The water flows past you carrying warmth from the day side toward the cold night side. Where the river meets the frozen boundary, it forms spectacular ice formations. Waterfalls frozen in time. Ice caves that glow with reflected sunset light. The boundary between your twilight zone and the frozen night side would be magical. Here, the eternal sunset light meets the eternal darkness. Ice formations catch and scatter the orange and red light, creating sculptures that gleam like amber and ruby. Natural art galleries carved by wind and water and time. On the other boundary, where your twilight zone meets the scorching day side, different wonders appear. Hot springs might bubble up from underground. Steam would rise and catch the sunset light, creating ethereal displays of color and motion. Geysers might shoot warm water high into the twilight sky. The geology of tidally locked worlds creates its own beauty. The day side expands from constant heat. The night side contracts from constant cold. This creates stress and movement in the planet's crust. Earthquakes and volcanic activity follow the boundaries between temperature zones. In your twilight zone, you might see volcanoes that glow not with fire, but with reflected sunset light. Lava flows that move slowly across the landscape, never cooling completely because the temperature stays moderate, never getting hot enough to be dangerous. The night sky in your twilight zone would be extraordinary. Turn away from the eternal sunset and look toward the dark side. The stars shine with perfect clarity. No atmosphere heated by daylight to blur their images. No city lights to wash out their glow. Just pure starlight in perfect darkness. But the most beautiful sight would be the boundary itself. The line where light meets dark. This terminator line would glow softly as sunlight scatters through the atmosphere. It would shimmer and dance as the air moves. A ribbon of light separating day from night. Hot from cold. Known from unknown. Some tidally locked worlds might have moons that orbit around them. These moons would create eclipses as they pass between the planet and its sun. For a few hours, the eternal sunset would dim. The twilight zone would grow cooler. Then, as the moon moves on, the light returns. The warmth flows back. The eternal sunset resumes. Living in the twilight zone would teach you new ways to think about time. Without day and night cycles, your body would find new rhythms. Perhaps you would sleep when the winds blow cold from the night side. Wake when warm breezes flow in from the day side. Your life would follow the breathing of the planet itself. As you rest in this eternal twilight, feeling the constant gentle warmth of the motionless sun on your face, your mind begins to wonder about other impossible worlds. Places where the very rain that falls might be made of diamonds, where storms scatter treasures across alien landscapes. Imagine standing beneath a sky where raindrops are made of diamonds. Each drop catches the light of an alien sun and breaks it into rainbows. This is not fantasy. This is the reality on worlds where carbon and pressure create the most precious storms in the universe. Deep in space, scientists have found planets where diamonds actually fall from the sky. These worlds are rich in carbon, the same element that makes up your pencil lead. But under the right conditions of heat and pressure, carbon transforms into something magical. It becomes diamond. Picture yourself on such a world. The sky above you swirls with thick clouds. But these are not water clouds. They are made of carbon compounds floating in a dense atmosphere. The air around you feels heavy, rich with the building blocks of diamonds. The sun in this alien sky might be a bright blue star. Its intense light heats the carbon-rich atmosphere to thousands of degrees. Or it could be a red giant star, cooking the planet slowly with gentle but persistent warmth. Either way, the heat and pressure work together to create miracles. High in the atmosphere, carbon atoms begin to bond together in perfect patterns. Three-dimensional structures that are harder than any earthly stone. Diamond crystals start small. Just a few atoms linked together. But as they fall through the thick air, they grow larger, gathering more carbon atoms like snowflakes gathering ice. These diamond raindrops would be unlike any rain you know. They would be tiny at first. Microscopic gems no bigger than dust particles. But some would grow as they fall, becoming crystals the size of pebbles. Or even larger. Precious stones tumbling through an alien sky. The sound of diamond rain would be unique. Unlike the soft patter of water drops, diamond rain would create a gentle tinkling, like wind chimes made of crystal. Each drop would ring with a pure, clear note as it strikes the ground. The entire landscape would fill with this crystalline music. Look around at the surface of this diamond world. The ground beneath your feet glitters with billions of fallen gems. Diamonds carpet the landscape like gravel. Hills and valleys sparkle in the starlight. Rivers flow over beds of precious stones. What would be priceless treasures on Earth are simply part of the geology here. The light on this world behaves in extraordinary ways. Each diamond in the air acts like a tiny prism, breaking sunlight into its component colors. Red, orange, yellow, green, blue, indigo, violet. The air itself becomes filled with scattered rainbows. Every direction you look, spectrums of color dance and play. During a diamond storm, the spectacle would be breathtaking. Millions of tiny gems fall through the atmosphere, each one catching and scattering light. The entire sky would sparkle like a vast chandelier. Rainbows would streak across the heavens in curtains of pure color. The sunset on a diamond rain planet would be unlike anything else in the universe. As the sun approaches the horizon, its light passes through layers of falling diamonds. The gems bend and twist the light in countless directions. What begins as simple sunlight becomes a symphony of scattered colors. The sun itself might appear to multiply. Refracted through falling diamonds, one sun could look like dozens. Each diamond drop acts like a tiny lens, creating multiple images of the setting star. The horizon would be filled with dancing suns. All slightly different colors. All moving independently as the diamonds fall. Water might exist on these worlds too. Hidden beneath the diamond surface. When water interacts with falling diamonds, it creates even more beauty. The gems would float in pools and lakes like living jewels. Each movement of the water would create new patterns of reflected light. The geology of diamond worlds would be fascinating. Over millions of years, diamond rain builds up layers of crystalline rock. Mountains made entirely of compressed diamonds. Valleys carved by rivers flowing over beds of gems. Caves lined with crystal formations that would make earthly cathedrals seem plain. But not all the carbon becomes diamond. Some forms graphite instead. The same material in your pencil. On these worlds, graphite and diamond exist side by side. Black carbon next to clear crystal. The contrast would create landscapes of stunning beauty. Dark valleys leading to sparkling peaks. The atmosphere of diamond worlds would be thick and complex. The air might be mostly hydrogen and helium, with clouds of carbon compounds floating throughout. Lightning in these clouds would be spectacular. Electric bolts passing through carbon-rich air would create brief moments of intense heat and pressure, forging new diamonds in the sky. The temperature on these worlds varies greatly depending on their distance from their star. Some diamond planets orbit close to their suns. The diamonds that form there would be created in furnace-like heat. Other diamond worlds sit farther out in the cold of space. Their diamond formation happens slowly, creating perfect crystals over thousands of years. Plant life on diamond worlds would face unique challenges. Any vegetation would need to grow in soil made partly of diamonds. Roots would have to push through crystalline ground. Leaves would be constantly sprinkled with tiny gems. The plants themselves might evolve to use the scattered light from diamonds, creating their own internal rainbows for photosynthesis. Animals on such worlds would adapt in remarkable ways. Their eyes might evolve to handle the constant sparkle and scatter of light. They might develop ways to distinguish between different types of carbon crystals, learning which diamonds are safe to walk on and which might be sharp enough to cut. The night sky on a diamond rain planet would be magical. Even in darkness, starlight would catch on diamonds in the air, creating a subtle sparkle that never completely fades. The surface would glitter softly with reflected light from distant stars, like being surrounded by a galaxy made of gems. Some scientists believe that diamond rain might be common in the universe. Many planets rich in carbon could experience these crystalline storms. Each world would create its own varieties of diamonds. Some clear as glass. Others colored by trace elements. Blue diamonds. Pink diamonds. Yellow diamonds falling like colored snow. As you stand in this glittering wonderland, feeling diamond dust settle softly on your shoulders, you begin to imagine what other extremes exist in the cosmic neighborhood. Not all alien worlds sparkle with precious stones. Some grow so large and massive that their very atmosphere becomes a crushing weight, bending light in ways that challenge imagination. Imagine stepping onto a world where everything feels twice as heavy as it should. Your footsteps press deeper into the ground. Your arms feel like they are moving through thick honey. This is a super-Earth. A planet larger and more massive than your home world. The gravity here pulls at you with invisible hands. What weighs 10 pounds on Earth weighs 20 pounds here. Your body adapts slowly to this new weight. But your eyes immediately notice something extraordinary about the sky above you. The atmosphere on this super-Earth is incredibly thick. Much thicker than Earth's thin shell of air. Here, the atmosphere presses down like a heavy blanket. The air is so dense you could almost swim through it. So rich with particles that light behaves in magical ways. Look up at the sun in this alien sky. It appears larger than it should. Rounder. The thick atmosphere acts like a giant lens, bending and focusing the sunlight, making the sun seem to swell and pulse as you watch. Sometimes it looks perfectly circular. Sometimes it stretches into an oval shape. The light from this sun travels differently here. On Earth, sunlight passes through your thin atmosphere in almost straight lines. But here, the dense air bends every ray of light. Curves it. Twists it. Like light passing through water or thick glass. This bending of light creates wonders you have never seen. The sun might appear to be in two places at once. One image where it really is. Another image created by light bent through the thick air. Sometimes you see 3 or 4 suns. All slightly different colors. All dancing slowly across the sky. As afternoon moves toward evening on your super-Earth, the magic truly begins. The sun starts its descent toward the horizon. But in this thick atmosphere, sunset becomes a performance that lasts for hours. Not the quick 15-minute sunset of your home world. The dense air acts like layers of invisible prisms. Each layer bends light at a slightly different angle. Red light bends one way. Blue light bends another. Green light follows its own path. The result is a sun that separates into a rainbow as it sets. Watch as the setting sun begins to stretch across the horizon. Instead of one round disk, you see bands of color. Red at the bottom. Orange above that. Yellow. Green. Blue. Violet at the top. The sun becomes a vertical rainbow slowly sinking into the thick air. But the atmosphere does more than just separate colors. It also creates mirages on a planetary scale. Hot air near the ground rises and mixes with cooler air above. This creates layers of different density. Each layer bends light differently. The horizon itself becomes fluid and uncertain. Mountains in the distance might appear to float in the air. Lakes might seem to hang upside down in the sky. The boundary between land and sky blurs and shifts constantly. Reality becomes dreamlike. Colors on this world are more intense than anything on Earth. The thick atmosphere scatters light in complex ways. Blue light bounces between particles millions of times before reaching your eyes. This creates blue so deep they seem to glow from within. Purple so rich they look like liquid velvet. The sunset colors here do not just paint the western sky. They spread in all directions. The thick air carries light around the curve of the planet. Even when the sun sets in the west, the eastern sky glows with reflected sunset colors. The entire world becomes wrapped in bands of colored light. Clouds on super-Earths form differently than Earth clouds. The intense gravity pulls water vapor down quickly. But the thick atmosphere supports clouds that are incredibly dense. These clouds do not just float through the sky. They sink slowly like heavy curtains. When sunset light passes through these dense clouds, spectacular things happen. The clouds act like three-dimensional prisms, breaking light into patterns that swirl and flow. Sunset becomes a light show projected onto a screen of water droplets and ice crystals. The weather on super-Earths moves with strange rhythms. The thick atmosphere holds heat for a long time. Temperature changes happen slowly. Storms build gradually over days or weeks. When they finally arrive, they move like slow rivers of wind and rain. During these atmospheric storms, sunset takes on an otherworldly quality. Lightning flashes through the dense air create momentary windows. Sudden glimpses of the sun through breaks in the clouds. These lightning sunsets pulse and flicker like strobe lights painting the thick sky. The air pressure on your super-Earth affects everything. Sound travels differently through the dense atmosphere. Your voice sounds deeper, richer. Birds, if they existed here, would need to flap their wings differently. The thick air both supports them better and resists their movement more. Water behaves strangely too. Rain falls more slowly through the thick air. Each drop encounters more resistance. Raindrops have time to grow larger before they reach the ground. When they finally arrive, they are gentle giants. Soft spheres of water that barely splash when they land. The seasons on super-Earths last longer because of the planet's greater mass. It takes more energy to heat or cool such a massive world. Summer arrives slowly and stays for months. Winter creeps in gradually and lingers. The thick atmosphere holds onto each season like a memory that fades slowly. Rivers and lakes on this world reflect the complex sky in amazing ways. The water surface acts like a mirror for the bent and twisted light. Reflections become abstract art. Sunset colors ripple and flow across every body of water, creating paintings that change constantly with every breeze. Plant life on super-Earths would evolve to use the complex light patterns. Leaves might be designed to catch light coming from multiple directions at once. Flowers could be tuned to specific colors that penetrate the thick atmosphere best. Gardens would be riots of impossible colors and shapes. The night sky on a super-Earth reveals different secrets. Stars appear to twinkle more dramatically through the thick atmosphere. Their light bends and shifts constantly, creating the impression that the stars are dancing. Some stars might appear to split into multiple colors, like tiny fireworks frozen in the sky. As you stand on this heavy world, feeling the dense air press against your skin, watching the sun stretch into bands of color across the thick horizon, your mind begins to drift toward even stranger places. Worlds where the very air glows with metallic fire, where sunset means watching liquid metal rain from burning skies. Float with your imagination to a world unlike any other. A gas giant planet that orbits so close to its star that it completes one full year in just a few Earth days. Here, the heat is so intense that metals become gas. Iron floats in the air like invisible mist. Titanium forms clouds that drift across burning skies. This is a hot Jupiter. A planet similar in size to Jupiter but positioned where Mercury orbits your Sun. The star blazes overhead with tremendous power. Its light is so intense that the daytime temperature reaches thousands of degrees. Hot enough to melt copper. Hot enough to turn solid rock into vapor. You cannot stand on this world because there is no solid surface. Hot Jupiters are made entirely of gas and liquid. But imagine floating in the upper atmosphere where the temperature drops just enough for you to survive. Here, in the cooler heights, metals begin to condense from gas back into tiny droplets. Look around at this alien sky. The air itself glows with metallic colors. Iron vapor creates a deep rust-red hue that permeates everything. Sodium makes the sky pulse with orange light. Potassium adds hints of violet. The entire atmosphere shimmers like a forge where metals are constantly melting and cooling. The star that heats this world appears enormous in the sky, so close that it fills a quarter of the heavens. Its surface shows spots and flares with frightening detail. Solar storms leap millions of miles into space. The light and heat streaming from this nearby star would be overwhelming to eyes adapted to your gentle yellow sun. Weather on hot Jupiters follows patterns driven by extreme temperature differences. The side facing the star bakes in constant heat. The side facing away stays relatively cooler. This creates winds that scream around the planet at thousands of miles per hour. Faster than any hurricane on Earth. These winds carry metals with them. Iron vapor streams from the hot side to the cool side. There it condenses into tiny droplets. Then the wind carries these iron droplets back toward the heat, where they evaporate again. This creates a continuous cycle of metal weather unlike anything in your solar system. Clouds on hot Jupiters are made of liquid metals. Picture clouds of molten iron drifting through the burning sky. Drops of liquid titanium falling like rain. These metal clouds glow with their own heat, creating a sky that burns with internal fire even without direct starlight. The sunset on such a world would be a spectacle beyond imagination. As the massive star begins to set, its light passes through layers of metallic vapor. Each type of metal absorbs and reflects different colors of light. Iron vapor makes the sun appear deep red. Sodium vapor adds brilliant orange streaks. But the most amazing part of a hot Jupiter sunset is the metal rain that begins as temperatures drop. As the star moves toward the horizon, the air grows just cool enough for metals to condense. First titanium droplets form. Then iron. Then copper and other metals create their own gentle precipitation. This metal rain would look like liquid jewels falling from the sky. Copper rain would gleam like pennies in the starlight. Iron rain would appear as silvery drops with hints of red. Titanium rain would fall in droplets that shine like liquid mirrors. Each type of metal creates its own beautiful cascade. The sound of metal rain would be unlike anything on Earth. Liquid iron striking metal surfaces would create a deep ringing tone. Copper drops would make softer chiming sounds. The entire atmosphere would fill with metallic music as different metals fall at different rates and create their own unique notes. Lightning on hot Jupiters would be spectacular. The extreme heat and metal-rich atmosphere create perfect conditions for electrical storms. But these are not ordinary lightning bolts. They are made of vaporized metals conducting electricity through the superheated air. Iron lightning. Copper lightning. Titanium lightning crackling through metallic clouds. The magnetic field around hot Jupiters is incredibly strong. Much stronger than Earth's magnetic field. This is because of all the metal vapor swirling through the atmosphere. Iron and other metals conduct electricity and magnetism very well. The entire planet becomes like a giant electromagnet floating in space. This powerful magnetic field creates aurora displays that would dwarf anything seen on Earth. Charged particles from the nearby star interact with the metal-rich atmosphere, creating sheets of colored light that stretch across the entire sky. Green iron aurora. Blue copper aurora. Purple titanium aurora dancing through the burning air. The day and night cycle on hot Jupiters happens quickly because they orbit so close to their stars. But the extreme heat means that nighttime never brings real cooling. Even the night side of the planet stays hot enough to keep many metals in gas form. True relief from the heat only comes in the upper atmosphere. Moons orbiting hot Jupiters would experience incredible tidal forces. The combination of the planet's strong gravity and the star's nearby pull would stretch and squeeze any moons constantly. This tidal heating might make the moons glow red hot themselves, creating a system where multiple worlds burn with internal heat. The chemistry happening in hot Jupiter atmospheres is complex and fascinating. Metals that never interact on Earth can mix freely as gases. Iron and copper vapor might combine to create new compounds. Titanium might bond with other elements in ways impossible at Earth's cool temperatures. Scientists study hot Jupiters by watching how they block their star's light when they pass in front of it. This creates a partial eclipse that reveals what metals are present in the atmosphere. Each metal absorbs specific colors of starlight. By studying which colors are missing, we learn what metals are floating in those distant burning skies. Some hot Jupiters are so close to their stars that they are actually losing atmosphere. The intense heat strips away the outer layers of gas. These planets leave trails of vaporized metal streaming behind them as they orbit. Like cosmic comets with tails made of iron and copper and titanium. The gravity on hot Jupiters is much stronger than Earth's gravity. If you could somehow stand on a solid surface, you would weigh several times more than normal. But the heat would make this impossible. Only in the cooler upper atmosphere could you imagine floating safely among the metallic clouds. As you drift through this realm of vaporized metals and liquid fire, feeling the heat of an alien star on your face, your mind begins to wonder about cooler places. Hidden worlds where water reigns supreme, where entire planets lie beneath miles of ice, holding secrets in their dark and mysterious depths. Imagine sinking slowly into an ocean that has no bottom you can see. No continents. No islands. Just water stretching in every direction to the horizon and beyond. This is an ocean world. A planet where water covers everything. Where the sea is not just a feature of the world but the world itself. You float suspended in this alien ocean. Above you, sunlight filters down through layers of water. The light grows dimmer and bluer as it descends. What began as bright yellow sunlight at the surface becomes a gentle blue glow around you. Soft and peaceful like floating inside a living sapphire. These ocean worlds exist throughout the universe. Some orbit close enough to their stars to have liquid water at the surface. Others stay frozen on top but hide vast oceans beneath miles of ice. Each type creates its own kind of underwater sunset. Its own version of beauty filtered through water and time. On the surface ocean worlds, sunset happens much like on Earth. But with one crucial difference. There is no land to break the view. The sun touches the water and spreads its reflection across an endless sea. The entire horizon glows with sunset colors. Orange and red and pink stretch as far as you can see in every direction. But the real magic happens beneath the surface. As the sun sets above, its light travels down through the water in beams and shafts. These underwater sunbeams dance and sway with the movement of the waves, creating a light show that moves in 3 dimensions around you. Water absorbs different colors of light at different depths. Red light disappears first. Within 30 feet of the surface, all the red sunset colors have been filtered out. Orange follows next. Then yellow. By the time you reach 100 feet deep, only blue and green light remain. This creates layers of color in the ocean world sunset. Near the surface, you see the full spectrum of sunset hues. Deeper down, you float in a world of blue and green twilight. Even deeper, only the purest blue light penetrates. Like being inside a liquid sky that glows with its own inner light. Marine snow drifts constantly through these alien oceans. Tiny particles of organic matter falling slowly through the water like underwater snowflakes. When sunset light hits this marine snow, it creates ethereal displays. Millions of particles catch and scatter the light, making the water itself seem to sparkle and glow. But some ocean worlds are even more mysterious. These planets have frozen surfaces covered by ice sheets miles thick. The real ocean lies hidden beneath this ice. Dark and secret. Cut off from direct sunlight. Yet even here, a form of sunset exists. Imagine yourself beneath such an ice sheet, swimming in an ocean that has never seen direct starlight. Above you, ice stretches up and up, so thick that it blocks out the sun completely. Yet this underwater world is not completely dark. Light filters through the ice in subtle ways. The ice itself becomes a filter for sunlight. As the sun moves across the surface far above, its light passes through the frozen ceiling of your underwater world. The ice bends and scatters this light, creating patterns that shift and change as the sun moves. An ice-filtered sunset that paints the ocean depths in shades of pale blue and silver. Cracks in the ice create underwater windows. Shafts of light that penetrate directly down into the hidden ocean. These light shafts move and dance as the ice shifts above, creating dramatic columns of illumination that sweep across the ocean floor like searchlights from another world. But the most beautiful sunsets in these ice-covered oceans come from thermal vents. Deep on the ocean floor, heat from the planet's interior creates underwater geysers. Hot water shoots up from the depths, carrying minerals and heat into the cold ocean above. These thermal vents glow with their own light. Not from fire, but from the chemical reactions happening where hot and cold water meet. The minerals in the hot water create colors when they dissolve into the cold ocean. Reds and yellows and oranges bloom like underwater flowers around each vent. When the filtered sunlight from above meets the glow from thermal vents below, magic happens. The two light sources blend and interact, creating underwater aurora that dance through the water in waves of color. Blue sunlight from above mixes with red and orange vent glow from below. The result is a sunset that happens in 3 dimensions around you. Life thrives around these thermal vents in the dark oceans. Strange creatures that have never seen sunlight. They use the chemicals from the vents for energy instead of relying on photosynthesis. These alien life forms create their own light shows. Bioluminescent displays that add to the underwater sunset. Fish that glow blue swim through the vent-warmed water. Jellyfish that pulse with internal light drift past like living lanterns. Bacteria that shine green coat the rocks around the thermal vents. Together, they create a sunset made not from sunlight but from life itself. A biological aurora that paints the dark ocean with living color. The currents in ocean worlds create underwater weather systems. Warm water from thermal vents rises toward the ice ceiling above. Cold water sinks toward the ocean floor. This circulation carries the colored water from the vents throughout the ocean, spreading the underwater sunset across vast distances. Sometimes the circulation brings vent-warmed water close to the ice ceiling. When this happens, the ice begins to melt from below. This creates underwater rain. Droplets of fresh water falling through salt water. Each droplet catches and bends light differently, creating tiny lenses that focus the filtered sunlight into concentrated beams. The tides on ocean worlds would be different from Earth's tides. With no continents to block their movement, tidal forces would create planetary waves. Massive currents that circle the entire world. These global tides would carry the colors and lights of underwater sunsets around the planet, creating a constantly moving display of aquatic beauty. In the deepest parts of these alien oceans, pressure creates its own wonders. Water under extreme pressure behaves differently. It becomes denser, more viscous. Light travels through it in curved paths instead of straight lines. This creates optical effects that bend and twist the thermal vent colors into impossible shapes. The sound in these underwater worlds would be hauntingly beautiful. Whale-like creatures, if they exist, would sing songs that carry for thousands of miles through the water. The thermal vents would add their own sounds. Deep rumbles and hisses as hot water meets cold, creating an underwater symphony to accompany the visual sunset. As you float in this liquid universe, surrounded by colors that dance through water instead of air, feeling the gentle currents carry you through an ocean that stretches beyond all horizons, your thoughts begin to drift toward home. Toward the familiar warmth of a sun you know, painting skies you understand. Let your mind drift slowly back across the vast distances of space. Back from the diamond rain planets and metallic skies. Back from the underwater auroras and tidally locked worlds. Back to the small blue planet that spins quietly around a middle-aged yellow star. Back home to Earth. Feel your feet touch solid ground again. Familiar ground made of rock and soil instead of frozen methane or crystalline diamonds. The gravity feels just right. Not too heavy like the super-Earths you visited. Not too light like the small moons. Just the perfect pull that your body knows and trusts. Look up at your home sky. How simple it seems after all you have witnessed. Just one sun hanging there. Not two dancing partners or a massive red ember or a brilliant blue giant. Just your sun. Yellow and warm and exactly the right size. Exactly the right distance away. The air around you feels thin and clean after the thick methane atmospheres and crushing super-Earth pressures you imagined. You can breathe easily. The oxygen and nitrogen mixture that fills your lungs is perfectly balanced for life like yours. Not too hot to melt metals. Not too cold to freeze the air itself. As evening approaches, you prepare to witness something you have seen thousands of times before. Yet now, after your journey to alien worlds, this familiar sunset feels different. More precious. More remarkable. You understand now how special your Earth's golden hour truly is. The sun begins its descent toward the western horizon. It moves at just the right speed. Not the slow eternal sunset of tidally locked worlds. Not the quick metal-melting plunge of hot Jupiters. Just a gentle, measured pace that gives you time to appreciate the changing light. Your sun maintains its perfect circular shape as it sets. No atmospheric lenses stretch it into ovals. No binary companion splits it into multiple images. No methane haze bends it into impossible curves. It remains simply and beautifully itself. A golden disk against a blue sky turning orange. The colors that paint your evening sky are subtle and soft. No electric blue methane glows. No metallic copper gleams. No diamond sparkles or crystalline refractions. Just the gentle progression of yellow to orange to red to purple. Colors that evolved alongside your eyes. Colors that feel like home. Watch how the light changes everything it touches. The grass at your feet glows green in the golden light. Not the burgundy of red dwarf worlds or the blue-tinted vegetation of methane planets. Just green. The color of life that knows your sun intimately. That has learned to capture its yellow light perfectly. The clouds above you are made of simple water vapor. They catch the sunset light and hold it gently. Soft white clouds turn pink and orange and gold. No metallic copper clouds. No diamond crystal formations. No iron vapor streaming across the sky. Just water. Pure earth water reflecting the light of your home star. Your Earth's atmosphere creates the sunset colors through a process both simple and elegant. Blue light scatters away during the day. Red and orange light travels straight to your eyes at sunset. This is why your sky is blue during the day and red at evening. A daily rhythm that has comforted countless generations before you. The air pressure here feels perfect against your skin. Not the crushing weight of super-Earth atmospheres. Not the thin wisps of planets with weak gravity. Just the right pressure to let you breathe comfortably while creating beautiful weather patterns. Gentle breezes that carry the scent of growing things. Listen to the sounds of your Earth evening. Birds singing their twilight songs. Leaves rustling in trees. Maybe distant voices of other people enjoying the same sunset you watch. No crystalline chiming of diamond rain. No metallic thunder of metal storms. Just the soft, organic sounds of a living world. Temperature on Earth changes gradually and predictably. Your sun warms the day without melting metals into vapor. Your nights cool without freezing the air itself. The seasons change slowly over months. Not the centuries-long seasons of red dwarf worlds or the extreme swings of planets with eccentric orbits. The horizon stretches away from you in all directions. Familiar shapes of hills and trees and buildings. Landscapes carved by flowing water and growing plants. Not the crystal formations of diamond worlds or the thermal vent glows of ocean planets. Just Earth. Shaped by Earth processes over Earth time. Your moon rises as the sun sets. A gentle silver companion that creates tides and lights the night. Not multiple moons causing chaotic gravitational forces. Not the absence of any moon at all. Just Luna. Your faithful satellite that has watched over Earth for billions of years. The night sky that emerges as darkness falls is filled with single points of light. Stars that appear steady and constant. You know now that many of these stars have their own planets. Their own sunsets. Their own alien beauties. But from here, they are simply lights in the darkness. Beacons that remind you of the vast universe beyond. As you stand in the gathering dusk of your home world, you realize something profound. Earth's sunset is not the most dramatic you have imagined. Not the most colorful or complex or exotic. But it is perfectly suited for you. For eyes that evolved under this particular star. For a mind that finds peace in these particular colors. Your Earth sunset happens at human scale. It lasts long enough for you to notice and appreciate, but not so long that you grow tired of waiting. It provides just enough light to see clearly, but not so much that it hurts your eyes. It offers just enough color to inspire wonder, but not so much that it overwhelms your senses. The temperature during your Earth sunset feels comfortable against your skin. Warm enough to enjoy without protective clothing. Cool enough to refresh you after the heat of the day. Not the melting heat of hot Jupiter atmospheres or the freezing cold of distant ice worlds. Just right. Every sunset on Earth is slightly different yet fundamentally the same. Clouds move in new patterns. Seasons change the angle of light. Weather adds its own variations. But the basic beauty remains constant. A daily gift from your sun to anyone who takes time to watch. As the last light fades from your western sky and the first stars appear overhead, you carry with you the memory of all the alien sunsets you have visited in your imagination. They make your own sunset seem not ordinary, but extraordinary in its perfect simplicity. Tonight, as you rest beneath the gentle protection of Earth's familiar atmosphere, you know that somewhere among those distant stars, other sunsets are painting other skies in ways beyond your wildest dreams, while you drift peacefully to sleep under the most beautiful sunset of all.